Earth's minerals and rocks. Rocks and minerals are all around us. Turn around and see the room that you're living in. The walls, if you're living in a brick house, the bricks are made up of rocks. If you're living in a wooden house, the woods are covered with something called plaster, which is a mineral. Yes? So, what do these minerals and rocks help us with? So, they help us develop new technologies and are used in our everyday lives. Our use of rocks and minerals include building materials, cosmetics, cars, roads, and appliances. All these minerals and rocks are found on the surface of the earth, yes? So, to learn about the surface of the earth, we are supposed to also understand about the earth's interior. But we cannot dig even halfway through the crust, yes? All these technologies we have until now, we have still not been able to dug more than halfway of the crust. What is the natural way that the earth's surface connects with the earth's interior? That's right, volcanoes. So this is the only way that the Earth's interior connects with the surface of the Earth. The rocks that are found in the surface are ones that were picked up and carried to the surface by the melted rocks that are later hardened. So to learn about Earth's interior, the scientists have found other ways to study the unseen interior of the Earth. Their method are by two ways. One is direct evidence from rock samples, and two is indirect evidence from seismic waves. Let's understand these two ways a little bit in detail. First method was direct evidence from rock samples. Yes, rocks collected from digging or from volcanic eruptions provide us information of how the earth and the matter flow in the deeper layers of the earth. A fun fact about Kola borehole is it's 9-inch in diameter, but it's 12,262 meters depth. That's a natural picture of Kola borehole. It took almost 20 years to reach that depth, not even half of the distance of the crust. So here you can see how deep that they have dug the super deep borehole. It's more deep than the Mariana Trench that we have learned about in our previous lessons. We learned that the Mariana Trench is the deepest trench that has ever been recorded in the ocean. Yes, so these scientists they tried to dig a hole that was deeper than that of Mariana Trench. Another comparison would be has more kilometers than the Mount Everest. If you notice, the Mount Everest is 8.9 kilometers, whereas the Kola super deep borehole is 12.3 kilometers. The Kola hole was abandoned in 1992 when drillers encountered higher than expected temperatures, which was 350 C degree Fahrenheit. Moving on to the next slide, what was the second way that the scientists used to study the inner structures of the earth? It was the indirect evidence from seismic waves. Yes, there are two types of seismic waves, the P waves and the S waves. So here you have a picture of the layers of the earth and you see that the waves are traveling through. So that blue arrow is P wave and the yellow arrow is S wave. P waves have higher velocity, whereas S waves have lesser velocity. By velocity, you can imagine that the P waves travel faster and the S waves travel slower. P waves travel through solid and liquid. That's why, if you notice in this picture, the P waves can travel through the crust and through the mantle because the mantle is semi-solid, yes, and also through the outer core, and also through the inner core. Though the core is liquid in nature, the P wave can still cross through it. And if you notice that the S wave, the yellow arrows, they are never crossing the liquid part of the earth. That's why the S waves only travel through solids. So the S wave starts in the crust and only goes as far as the mantle. It can never cross through the liquid part of the inner core. In here, we can see a comparison of how the P wave's velocity is higher compared to the S wave's velocity. In soil, the P wave's velocity is 300 to 700 meters per second, and S wave's velocity in soil is just 100 to 300 meters per second. All of the minerals, the soil, the dry sand, the limestone, and the granite, the velocity of P wave is higher compared to the velocity of S wave. Yes? So the speed at which the seismic wave travels depends on the property of the material, as you saw in here, that they are passing through. Denser a material is, faster a seismic wave travels. So by understanding all the speed and the velocity of P and S waves, the scientists get a better knowledge of how the Earth's layers are arranged. Scientists use this information, the rock evidence, and the seismic waves to help them determine the structure of the Earth. That's how we know that there are four layers of the Earth: the crust, the mantle, the core, and the inner core. So we don't have to go in detail about the layers of the Earth because we have already covered about it in our previous lessons. So moving on to a little bit in depth about minerals and rocks. Let's start with minerals. Minerals are building block of any solid part of the earth. Okay, that's the rock or the stone. If you try to zoom in the composition of a rock, you will find different minerals in it. So for example, this granite is a rock. In this rock, if you study further, you will understand that there are so many minerals in it. It's made up of minerals like mica, feldspar, hornblende, and quartz. So you can imagine this like different colored Lego pieces. Each of this, imagine that the mica is the blue Lego piece, and the feldspar is the red one, and the hornblende is the green Lego piece, and quartz is the yellow Lego piece. So when you put all these Lego pieces together, it creates one rock. So now let's learn a little bit about minerals' physical properties. Minerals have four physical properties: hardness, shape, luster, and color. Hardness. The most hardest mineral that we know is the diamond. If you see the scale of hardness, it is the most hardest. And talc, the least hardest mineral that we have. So if you see the scale of hardness, it's at the bottom. Shape. Minerals can be in regular shapes or irregular shapes. An example of regular shape is argonnite, and an example of irregular shape is malachite. Luster. What does luster mean? How shiny the mineral is. Can you imagine which would be the high luster one? It would be the gold. And the low luster would be talc. Color. So the minerals can be of different variety of colors. Here I have used some of the colors, but there are more than these. Here we see the blue one called azurite and emerald, sulfur. This looks pretty, the rose quartz. All these are different colored minerals. So now that we have finished with the minerals' physical properties, now let's go in a little depth about minerals' formation, how they are formed. So in the earth, minerals are also found in water, yes. So in this part, whenever there is evaporation of water, the minerals are formed on the beaches. Minerals can also be formed as the lava cools. Yes, because this lava is going to take all this minerals from the inner earth to the surface. When it comes in contact with the cooler temperature, it hardens to form mineral. Minerals are also formed as magma cools. So those are the 3 points for the formation of minerals. Now let's learn about stones or rocks. Both are same. Rocks or stones are the solid part of the earth and can be very different from each other. Rocks and stones are made up of different types of minerals. We just learned about that, yes? So the rocks are made up of different minerals. We saw the same information in our previous slides. There are 3 types of rocks classified by how they are formed. It's sedimentary rocks, metamorphic rocks, and igneous rocks. So let's start with sedimentary rocks. The word sediment comes from the Latin word sedimentum, meaning sink down. by the process of weathering and erosion, which means basically break down. By the process of breaking down, rocks gradually break up into sediments. Okay, so the rocks that are on the surface, they break down, they undergo this process called weathering and erosion, which is basically breakup of the rocks, and these rocks become sediments. After sediments gets buried underneath layers of fresh sediments. So there's this one layer of sediments because of the breakup of the rocks, and then after a few years there's more sediments that gets piled up on top, and then after a few more years there are more sediments that gets piled up on top of the previous sediments. So by doing so, over long periods of time, layers of sediments become compacted and they are transformed into sedimentary rock. What does compacted means? They are basically pressed down. The layers of sediments keep pressing down the layers of sediments underneath, and they get compacted into sedimentary rock. Examples would be sandstone and limestone. Moving on to the next rock, that's the metamorphic rock that you see in here. The word metamorphic comes from the Greek word meta, which means change, and morph means shape, which means it changes shape. Rocks that are at the plate boundaries are subjected to intense heat and pressure. So you see a plate tectonic activity happening in here. Can you see that? So the rocks that are found near this plate tectonic activity can get more heat because there's magma and lava near here. Yes. So because of which they undergo extreme heat and pressure, which causes physical and chemical change in the rock's appearance and structure. So, because of the heat, the rock near here can change in their physical and chemical form, thereby creating a metamorphic rock. Moving on to the next rock, which is the igneous rock. The word igneous comes from the Latin word ignis, meaning fire. Some rocks gets heated deep inside the earth and melts into molten rock. Molten rocks are called magma when they are inside the earth, and lava when they are on the surface, when they come out of the inner parts of the earth, basically. As it cools, it crystallizes and solidifies to form igneous rocks. So what they are basically saying is the magma that's found in the inner part of the earth that comes out and creates this igneous rock because it hardens. Yes, once the lava is out, it hardens because of the cooler temperature of the earth, and those rocks are called igneous rock. Example of igneous rock are basalt and granite.